Section 4.4, solve for x. Now, the way we want to solve for x is we want to get them to have the same base, and once they get the same base, we can set their exponents equal to each other. So since both of these have a 2 base, we know that 4x minus 1 must be equal to 7. And that gives us an equation. 4x minus 1 is equal to 7. And we can solve for that. So 4x minus 1, we add 1 to undo the subtraction of 1. That gives me 4x is equal to 8. 7 plus 1 is 8. We undo the multiplication of x by 4 by dividing by 4. Whatever we do to one side, we do to the other, giving me x is equal to 2. Next one, we have 1 that is 2 to the 2x minus 1 power. We can't do a prime factorization beyond 2 there, but we can do a prime factorization of 32. So 32 divided by 2 is 16. Divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. We got a 1, so we know we're done. And how many of those do we end up with? We end up with 5 of those. So that would be the same as 2 to the 5th power. Okay, so now both of these have the 2 base, so we know 2x minus 1 must be equal to 5. Plus 1, cancel, cancel, 2x is equal to 6. We undo the multiplication of x by 2 by dividing by 2. Whatever we do to one side, we do to the other, and we end up with a 3. Alright, so solve the exponential equation, express solutions in terms of natural logarithms, then use a calculator to obtain decimal approximation, round to the 3 decimals. I want to solve for this x, but it's in an exponent. So the way I'm going to bring it down is I am going to take a natural log. But whatever I do to one side, I do to the other. So I took a natural log of 10 to the x power, which is x natural log of 10 is equal to the natural log of 3.91. Next, I want to solve for the x, but the x is being multiplied by the natural log of 10. So I'm going to divide it by the natural log of 10, and whatever I do to one side, I do to the other. So let's cancel out, leaving me x is equal to the natural log of 3.91 over the natural log of 10. The next one is 7 to the x minus 2 power is equal to 410. I'm going to take a natural log of both sides to get that x plus 2 down from up on top, pull it to the front. That gives me x plus 2 within parentheses of a natural log of 7 is equal to the natural log of 410. Next, I'm going to distribute this x and the 2 to the natural log of 7. So what I'll end up with is x natural log of 7 plus 2 natural log of 7, which is equal to the natural log of 410. Now I want to get this x by itself, but right now I'm going to get the x term, the entire x natural log of 7 by itself by undoing addition. And I undo addition by subtracting 2 natural logs of 7. Whatever I do to one side, I do to the other. 2 natural logs of 7. These cancel out, leaving me x natural log of 7 is equal to the natural log of 410 minus 2 natural log of 7. Now, I want to get the x by itself, so I'm going to divide it by natural log of 7. Whatever I do to one side, I do to the other, natural log of 7. Those cancel out, leaving me x is equal to natural log of 410 minus 2 natural log of 7 all over natural log of 7. There's a few things you could do. For instance, I have subtraction here, so I could move some of these around, but this is perfectly adequate. You could just plug this into your calculator and get the answer. You can manipulate a little bit more if you wanted to. So let's try the next one. Before I take the natural log of this to pull this exponent part down, I am going to get one term on this side. So what I'm going to do is I'm going to add 2 to both sides, and that would give me e 5x minus 3 is equal to 10,478. Then I want to take a natural log of both sides, and what that would allow me to do is pull this 5x minus 3 to the front, which would give me 5x minus 3 within parentheses, times the natural log of e, which by the way is just a 1, so it just goes away basically, of the natural log of 10,478. Next, we know we have 5x minus 3 is equal to the natural log of 10,478. So I add 3 to both sides to get my 5x by itself. And that gives me 5x is equal to natural log of 10,480, right? 78 plus 3 is 81. And then we undo the multiplication of x by dividing by 5. And whatever we do to one side, we do the other. 5's cancel out, leaving you x is equal to the natural log of 10,481 all over 5. All right, I calculated all of them. The first one I got a 0.592, and it continued on. That was approximately. The second one I got a 2.09 something something something. So there's approximation. And the next one I got a 1.85 approximately. So we want to solve the exponential equation and express the solutions in terms of logarithms. So same kind of thing. Now in both of these cases, we have exponents that contain variables that we're trying to solve for. So first step is we want to get those down. And we get those down by taking natural logs. And that allows us to pull these exponents down. So the first one we have 4x plus 2 times natural log of 7. The next one we have x plus 1 natural log of 6. Now I'm going to distribute it. So I'm going to distribute both the 4x to the natural log of 7 and the 2. And I'm going to distribute the x and the 1 to the natural log of 6. So what that does is that gives me 4x natural log of 7 plus 2 natural log of 7 equals x natural log of 6 plus 1 natural log of 6. I'm going to leave the 1 there if you want to. It's not necessary though. Now we want to get all the variables on one side. So we say minus x natural log of 6 minus x natural log of 6. And we want to get rid of the 2 natural logs of 7 on this side. We want to get all the constants on the other side. And 2 natural logs of 7 is a constant. It's just a very ugly looking constant, but it is a constant. It's irrational, but it is a constant. So these cancel out. And what that does, that leaves me 4x natural logs of 7 minus x natural log of 6 equals natural log of 6 plus 2 natural logs of 7. Now I can factor this x out of both of these. So I can put the x in front, and that leaves me 4 natural logs of 7 minus natural logs of 6 equals, I'm just going to leave this side so far, natural log of 6 plus 2 natural logs of 7. And you can do a little bit of algebraic manipulation there if you want to. So next, we can divide both sides by 4 natural log of 7 minus natural log of 6. So 4 natural log of 7 minus natural log of 6. These cancel out on this side, and that gives me x is equal to natural log of 6 plus 2 natural log of 7 over 4 natural log of 7 minus natural log of 6. And then we just approximate that in the calculator. So the next one, solve the following logarithmic equation. Be sure to reject any values of x that is not in the domain of the original logarithmic expression. So we know this is actually 2 to the 5th power. That's the base. This is the exponent, and this is the argument, is what the whole thing's equal to. So that was pretty easy to set that one up. Now, we know the domain, basically x plus 50 has to be greater than 0. So basically, x can't be, it has to be greater than negative 50. So we'll do this problem now. So 32 is equal to x plus 50. So we'd say minus 50, minus 50, cancel, cancel, and we end up with x is equal to 32 minus 50, which is negative 18. Over here, we can actually mush these together, so then we can use this to convert it to exponent. First, we want to mush this into one logarithm. So since these both have the same base, which is 3, I can say, well, log base 3, and then I multiply these together. X plus 6 times x plus 4 equals 1. So what that means is x plus 6 times x plus 4 has to be equal to 3, the base, and this is the exponent of 1. So basically all that's equal to 3. Okay. Now once we distribute this, this is going to turn this into a quadratic. So x times x is x squared. Then we say x times 4 is 4x. Then we'd say 6 times x is 6. Then we say 6 times 4 is 24. And that's all equal to 3. When we combine like terms, so x squared plus 4x plus 6x is 10x plus 24 is equal to 3. Then we want to set it equal to 0 and see if we can factor it, if we're going to use the zero factor property. There are other ways you can do it too, completing the square quadratic formula, but let's try factoring first. So minus 3, cancel, cancel. And what we end up with is x squared plus 10x. And 24 minus 3 is 21 is equal to 0. So let's see if we can factor this. So what, first of all, the square root of x squared is x. It ends in a positive, so they match in the middle as a positive. It means they're both going to be positive. We're looking for two numbers that we can multiply together to give you a positive 21 that if you added together would give you a 10. So that'd be 3 and 7, right? 3 plus 7 is 10. 3 times 7 is 21. Next, we're going to set each of these equal to 0. So x plus 3 is equal to 0. X plus 7 is equal to 0. And then solve. So we get x is equal to negative 3. And we get x is equal to negative 7. Now we have to go back and check it out, though. Okay, I just verbally did this one, but again, I was saying x plus 50 on the previous one has to be greater than 0. Therefore, x has to be greater than negative 50. Over here, it's x plus 6 has to be greater than 0. Therefore, x has to be greater than negative 6. X plus 4 is greater than 0. Therefore, x is greater than negative 4. Sorry. Yeah. So we have this, and we have this. Okay, so let's check out what we got here. We got one of these answers, which was a negative 7, and it said that x has to be greater than negative 6, and it has to be greater than negative 4. Well, this is not going to be valid. This is not going to be a valid answer because it's not within the domain, whereas negative 3 is. Now, you could plot this if you need a visual representation of this. You could just plot this if you wanted to. So you have your negative 3, you have your negative 7, and we said, well, negative 6 is good. So, but it has to, but the more constricted one is the negative 4. So basically we're talking about negative 6 right there, and then we have a negative 4 over here somewhere. Anyways, that basically this is valid from that point forward, the negative 4, and then this negative 7 is not valid. It's not within this interval of what's valid. We did a more explanatory version of this earlier, but anyways, you can kind of see, right? That's no good.